Hello, Dr. Zhenbo Wang. We very much appreciate you participating in this series of interviews. And so we are very curious about you and your project. Would you please introduce yourself first and tell us about your general interest in AI?
Oh yeah, sure. And yeah, I appreciate your time. And yeah, very nice to meeting with you both. And I'm Zhenbo Wang. I'm an assistant professor in mechanical aerospace and biomedical engineering department, the Tico College of Engineering at the UTK. And yeah, my research interest is focused on vehicle systems, many different types of vehicle systems, and specifically, I'm interested in some novel, control optimization in AI machine learning technologies for, space and air in the ground vehicle systems, and in recent years, I became more, interesting and more focused on like AI machine learning for some new emerging concepts like advanced air mobility or AAM, which is also the focus of my AI Tennessee seed project. And in this effort, we are looking at how to enable the future, safer and more efficient future air transportation systems. And yeah, we have a few projects going on in this area, including the AI Tennessee seed project. Yeah, I'd be happy to talk more details about that.
What is the title of your seed grant, and how many members does your team have, if anyone else is on it?
Well, yeah, sure. So the title of our project is AI-driven, user-centered, multidisciplinary or interdisciplinary solutions to the advanced regional air mobility, which is part of the advanced air mobility concept, and we focused on the Tennessee as the case study. So it's a pretty long title, but I mean, we're looking at a new concept for Tennessee applications. And on our team, we have 4 PI co-PIs. I'm the lead PI from the mechanical aerospace biomedical engineering department. I focus on air mobility and air transportation, and also in our team, we have Dr. Courtney Croney, with the co-PI professor from the College of Social Work. And she's expert in the social perception, public concerns on the novel transportation techniques. And also on the team, we have the assistant professor, Dr. Dong-Won Kim, from the electrical engineering and computer science department, and his expertise in the cybersecurity, embedded systems, and the edge computing with applications for both the ground air transportation systems. Of course, in this project, they focus on the air mobility problems. And also, we have associate professor Charles Liu from the business analytics and the statistics department. And yeah, he's in the the data analytics field and customer analytics, data mining, machine learning. But of course, this AI project, we look at all of those disciplines, for air mobility missions.
Excellent. This is definitely one of the larger teams. This is very impressive. And I know Courtney Cronley, we are the co-directors of the Center for the Study of Social Justice.
Could you please explain your project in a manner that would be understandable by a 5th grader?
Well, yeah, I will try. I mean, well, so look at the aircraft transportation, airplanes. So well, so one of the reasons, about, our project is that, in the US, we have, more than 5,000 airports. They are available for public use, but not used a lot actually. So what we are looking at now is how to take advantage of those existing resources and infrastructure to to enable some kind of more efficient future transportation, air transportation systems. And in this particular project, we are working on kind of very special small airplanes, or you can we call the flying cars. Flying cars can take off and land like a helicopter. And yeah, so those vehicles or air taxis or flying cars, they can help people get around of cities and also the rural areas or communities. So yeah, so we are looking at how to use the existing small airports to help more people travel quickly and easily, something like that. And yeah, so some specific interesting problem actually we are looking at since last year, the year one, and now in the year two of the project, is that first we would like to make sure that those new smaller planes or flying vehicles, they're safe, right? So safety is always the first. So that's number one. So how to coordinate or control, manage those more planes in a safe and efficient manner. And also we look at how many people we want to use those new surfaces, new planes. And yeah, as I mentioned earlier, so among those existing small airports, like in Tennessee, we have like the 79 public airports plus 148 small airports, private airports. So among those existing airports, where should we put those new flying routes or path for the vehicles in order to better use those small airports, and how they can be coordinated in safe ways. Those are some of the key challenges we're trying to address in this project.
So kind of sticking at this fifth grade level, how would you describe the challenge in solving this problem, and how would you frame, like, how does AI help you address this problem?
Well, that's a good question. Yeah, so and that's actually there's many challenges here. It's a pretty solid challenges because it's the new areas like ground transportation is more mature field, but the advanced mobility has been there for just a few years since 2016, and yeah, there are many challenges they are trying to address. For example, the like portal siting, or what we say the infrastructure planning, among all the existing airport, which airport or airports should we select to serve those travel demand, and what how much flight demand do we have, how to better predict those demand in order to make the better decision. So yeah, so we are leveraging some deep learning and deep neural networks to better predict those kind of demand, which we call the travel demand or flight demand prediction. So yeah, we have been finding that the AI models, and especially the deep learning techniques is pretty powerful and helpful to do that by using some open data set. That's one thing, and the other one is we find pretty powerful AI technologies to assist with the vehicle coordination. If we have like just a few vehicles in the air, that should be easy. But in the future, if pretty high demand, we say in high density flight operations, hundreds, thousands of vehicles, how to coordinate the vehicles operating in the air. So yeah, one of our students, so in this project, is developing some, AI machine learning models and algorithms to better coordinate the vehicles. And specifically, we're looking at, reinforced learning or multi-reinforced learning algorithms to do that. Yeah, those are, very, very important, providing some, significant opportunities to those challenging problems, which, were impossible to solve in the past. So, yeah.
Would you frame your research as purely research related, or would you say that it's more oriented towards an improving quality of life?
Well, yeah, I would not say that it's purely research related. Also it focuses a lot of research in this project. I mean, the project is intended to, we hope to significantly improve, people's life, the quality of our life, actually, by, advancing the general transportation system. So, yeah, I can give you some examples on that. So some kind of, impact on societal, social impact. So, first of all, I think, if successful, I mean, this whole area or, field are gonna help reduce the, traffic congestion, by kind of, taking some of the surface transportation, the traffic off the road into the air, so we can help reduce, the number of cars, on the road, and that will, lead to, some help reduce the traffic congestion, and then people can travel easier and faster, on the ground. And another thing I think we're gonna benefit in the society is that the advanced air mobility can help improve, the access to some rural or remote areas or communities. Because, as I said earlier, a lot of small airports, they're now, underutilized, and yeah, some techniques that we are developing through this project and several other projects, make better use those small airports to provide, some, travel options for the people, to travel in the rural areas, and especially to connect, some remote communities with some resources in the urban areas, and by connecting those small airports using the some air transportation or mobility techniques. And yeah, so another thing I think one of the benefit the society, which we may not look at in this project, but I think it's also a good point to mention, is the environmental benefit. Since, the future air mobility aircraft are gonna use, electricity, so we're gonna be electric powered aircraft. So that will reduce some, pollution, CO2 emissions, compared to the traditional, gasoline powered vehicles. I think that's another social impact, and of course, economic. It can create, more economic opportunities, new jobs in the this new area. Yeah, we hopefully can see, more jobs and economic growth in the general transportation field, manufacturing, flight maintenance, operations, of the new aircraft and some other related services. So yeah, so it was a lot of, effort and the research, but we do see its potential to improve the quality of life.
So let's jump to question 9, which is whether you have any concerns about the potential risks regarding the AI component of your research.
Risk of AI components of this research. Yeah, actually, yeah, of course. Yeah, we use AI in machine learning to develop, several components in this project, and several challenges I think, we really care about is, safety, right? Like if we call in the vehicles is some AI agents or components, sometimes those AI agents can make a mistake. So that cause some accidents, especially that's a big issue for aviation or air transportation, right? So actually I've been asking this question a lot. So if AI controlling a like flying car, a small plane, if it just doesn't work properly, so they're ever gonna crash. And what we need to do was we have to test. That's actually what we are doing now, is to test the AI components in the lot to make sure that it works correctly for all the times, consider as many conditions or cases as possible. So that's the safety concern we have on the AI components. And security, of course, is another big issue, right? So that's why we have Dr. Kim from ECS and our team to look at the cybersecurity aspect of the project through also some federal learning, and fancy AI technologies to avoid that the computers or flight computers be hacked by some people. So and at the end of the day, deploy this kind of technology, we don't have to create and make sure that the whole system is secure to protect those AI components from being hacked. Reliability issues, also some potential challenges with the AI controlled flying vehicles. Sometimes if the onboard computers or software, if they crash or stop working, if it happens, well, that'd be that'd be the tragedy. So what we have been doing is kind of definitely have kind of better backup system, backup plan, right? So if the AI agent or component just stop working, so we need to make sure there's another system that can take over and keep everyone safe. So so I think there are a lot of risks of AI components involved in our research, but those are just a few examples.
Right. I actually have a question that occurred to me during another interview that had to do with car transportation. Computers don't always work. Just the basic mechanics. They buffer at various points. They get stuck. They break down, etc. What basically what would happen if someone is in a plane or in a flying car or in a drone, etc. That's a person carrier, etc. And the computer just runs into technical difficulties, so to speak. Is part of the design to always have a backup system too at the same time in case this kind of thing happens, or?
Yes, well, I mean that's a pretty big problem actually in the advanced air mobility. That's what people call the contingency plans. I know NASA and FAA, they have a few groups of people are working on that. Developing some contingency plans for mitigating some potential breakdown of system, especially with the AI systems. So we always have to have this kind of backup plans. But I mean, before that, I said earlier, we in my area, you really have to do some plan. We have to plan for this possible breakdown through some very rigorous testing of whatever algorithm we are developing. So we are gonna all of them are gonna go through some rigorous simulations and hardware in the loop testing and risk assessment to predict or evaluate the potential risks or breakdown of the technology. But I mean, even if they already tested in onboard application on the aircraft, we're gonna have to have some emergency protocols. For example, in the AI, pilot can take care of maybe most of the routine jobs, but we always have the human pilot on board that's to monitor the whole process, and take over, the control, if necessary. So as a backup. Yeah.
Okay, the next question then is whether there are potential risks associated with not pursuing or developing the AI that is at the core of your project. So what
not pursuing AI.
Yeah. What if we don't do anything in this regard, and that things just happen as they are playing out?
That's a good question. Actually, we thought a lot about that. In this area, we also get a question like that. Why AI? Not other approaches. So, well, the reason we finally we decided still to try to use AI in this area. We use AI a lot. Most of part of project is because we believe we may miss some opportunity for the innovation, and also the opportunities for improving the whole efficiency of the system. So we believe, and also have been approved by our preliminary work, that AI has helped us a lot in making a safer and more efficient transportation system. So for example, use AI to help optimize, as I said, the prediction of the travel demand, and infrastructure planning, and also optimizing the route, the path, and managing the air traffic, and many other things. So and yeah, so without AI, I believe we're missing our opportunities, for those kind of new the innovations. And another thing I think we may not be able to do without AI is that well, the air mobility in our cases is pretty complex scenarios or operations, pretty challenging job. And so AI, we found AI is is a pretty good tool to help handle those complex scenarios, like how to coordinate multiple vehicles in the air, and how to ensure they don't collide with each other, and how to make sure that they can follow their flight path in real time. So with AI, we could make those problems. We can easily and efficiently solve those problems.
Yeah.
So I think those two risks.
I mean, your answers are excellent in terms of illustrating how this is very real, and how it's very important that AI is not something that's just being conducted by some researchers in some lab, etc. But this has very real, very concrete life consequences, etc. So these answers are very good, exactly what we were looking for.
Are there any ethical considerations and concerns that apply to and come with your AI Tennessee project?
Well, yeah, those well, the ethical issues is always something we are particularly interested in this project. That's why they have Dr. Corny and his team through some surveys or interviews with potential customers and end users in this area. So we would like to try to understand some of those ethical considerations. Like, I think one of the biggest concerns is the data security, or the privacy of the individuals that we're using those AI system, because in our research, AI system can collect a lot of personal data, the flight demand data, those transport data. So how to ensure that the data is safely and securely collected and stored, and also used in the correct way, while respecting the user's privacy, and also of course we need to comply with the data protection laws. So yeah, privacy and data security is some of the considerations, and also the transparency. I'm not sure. I believe maybe some other areas also have to share the same concerns. We have to make sure that the AI decision making process should be transparent, and the users really have to understand not only what decisions the AI agent make, but how. And yeah, so just in case of some potential errors or issues that may happen with those AI agents. And another thing that's coming to my mind is the public trust, of course, and the social acceptance of this novel technologies. Yeah, so we really need to engage not through this project, but some other project, like drone delivery, drone technology, also as part of the air mobility ecosystem. So how to engage? So we hope to engage with the public, community stakeholders in this effort. Yeah, so yeah, those are the factors that in my mind that may cause some ethical issues.
Does your AI Tennessee project have any bearing on matters and issues related to social justice?
Social justice. Yes. Yeah.
One of the issues you mentioned is essentially covering and making accessible rural areas.
Right. Yeah. So so actually that's all I hope. We hope that to make the access equitable. Yeah. So when I ensure that these new advanced air mobility technologies are accessible to all the segments of the society. Not underserved like the rich people, but some underserved, or disadvantaged, communities.
Yes.
And yeah, so for example, you have Dr. Charles Liu on the team, to look at how to design the kind of the pricing models or the service plans that may be affordable for all the income levels, and how to implement programs, provide I don't know, some discounts, some underserved communities, and also whatnot in the project, but the other project, we are partnering with the local government and organizations to ensure that those kind of services are accessible to everyone. Yeah, especially from the rural areas. Yeah, yes. So yeah. Nothing that I want to mention is that the job actually, the job displacement, some impact on the economy. So well, yeah. So in some our area, when we are developing some AI or autonomous systems, so that could lead to some job displacement, and how to address this kind of economic impact on the workers or the communities that might be affected by this kind of changes in technology. So that might be a good a big issue we may have. For example, we may create some programs that to train the workers, to upskill those workers who might be displaced by the AI, or offer some training programs in some new skills that might be required for operating or managing the AI technologies. Yeah, so I think that might be another problem that we may have in this area.
So the last question is whether we should have asked any other questions that you would have liked to have answered.
Other questions? I think we have talked a lot in the questions. Well, yeah, I really couldn't think about any question in my mind.
That's perfectly fine.
Yeah, but one particular thing I think might be a unique thing in my area is the regulation that I wanna bring out. Fly aircraft. The regulation is another big issue actually. Now we couldn't fly the aircraft where we want. We're gonna have to follow the FAA rules. So that's another thing that we found pretty challenging. So we need to work with the government agencies on that. Yeah. So but good thing that they related as I noticed that the Tennessee Department of Transportation, the Aeronautics Division, is working on kind of a air mobility group to address those kind of issues, including the safety and the regulation. Yeah, so I think it'll be a white paper gonna be released, by the end of this year.